long-winded and complex title I've got on this presentation. Fundamentally, it's about a sort of fairly straightforward problem, which is this one, or fairly straightforward situation. So a lot of the time in sort of modern software development, we find ourselves wanting to build a product feature that requires a new API or a new API feature to be built. So you have one or more consuming teams, be they mobile teams, microservices, web, whatever, who need something from a back end or from an API that they don't have yet. And then there'll be a producing team who are responsible for building those API features and shipping and running them probably. What I'm going to talk about additionally in this in this presentation is how mock APIs can be used to kind of accelerate this process. So that the problem with integrating around APIs is a very powerful way to decouple teams' activities within your organization or even between organizations. But it comes with its share of productivity issues, and we're going to talk a little bit about that, and then we're going to talk about how mocking and these kind of techniques can be brought to bear to improve this experience. And I'm going to do a quick demo of WireMock, our mocking product, and show specifically how this enables these kind of workflows. So first of all, for the benefit of anybody who isn't really familiar with the concept of API mocking, I'll attempt to summarize it here. Sort of at a high level, what we're doing is simulating the behavior of an API, but without having to kind of implement persistence logic or business logic or build the thing for real, essentially. And the reason for doing this is that mocks are cheap to create and cheap to change and to run. And as a result, they're this sort of malleable substitute we can use for the real API for kind of testing and prototyping and excuse me, for enabling consumers of APIs to kind of understand how they work and onboarding them and all sorts of stuff like that. So that's it in a nutshell. So next up, I'm going to talk about what I refer to as kind of the classic way of building sort of API-enabled products. Like we saw in the first or the second slide. This is what I've done a lot of kind of back in the day before kind of better tooling and techniques came about, and you still see a lot of people still kind of going about it this way. But essentially, the classic way is that a load of people from producing and consuming teams will go into a meeting room, sort of virtual or real, and discuss requirements and kind of generate some examples of how the API might work. Sort of think through the cases of the use cases required by the consuming teams, and maybe they'll sort of throw this in some notes into a kind of a whiteboard or a shared doc or a wiki or something like that. And then at the end of this session, that kind of collection of notes becomes the sort of specification for the thing to be built on both sides. And then we have this long period of the producing team going away and building a kind of version 1 of this API feature or this API. And the consuming team's kind of not being able to do very much at this point. Maybe they can build some of the bits of the product that don't involve API integration, but until the producing team ship something into a test environment that can be integrated with, consuming teams can't really make all that much kind of forward progress with their work. Then inevitably, when you do ship things into a test environment and you start validating the design by writing real client code against it, you find that there are shortcomings in the design, things you just didn't think of, things that don't quite work in practice that seemed great when they were on a whiteboard. So you go a few rounds of kind of iteration on this, and then eventually everybody gets to a point where the API design works. The client code is there to validate it, and then the API can be sort of published and documented, and the client features can be shipped, and we have a new product feature. As is hopefully clear from that, though, this isn't the most efficient way to work. There tends to be quite a lot of kind of sort of work that has to be kind of done serially rather than in parallel, and thus there's quite a lot of kind of time not being spent focused on shipping features, particularly on the sort of consuming side. An additional factor is that the feedback about the API design arrives very late, and that tends to mean that, like in most things in software, the later you get feedback about something, the higher the cost of changes. So if a producing team have committed to some implementation details in terms of producing an API that works a certain way, and then it's realized that actually this API design doesn't work for us, potentially there's some expensive rework involved. And kind of an additional downside of this, as we'll sort of see a little bit later, is that the work that happens up front, the co-design session, that sort of bag of notes kind of tends to not have a very long lifetime. It gets sort of thrown away as soon as the work sort of begins in earnest, and doesn't kind of deliver any long-term value. And actually, I'm going to argue that there are a number of ways in which that work done up front, can continue to provide value throughout the life cycle of this API. So next up, I'm going to talk about this kind of API first way of working, and this is something that's started to gain traction more recently, enabled by a number of great tools that are focused on co-authoring OpenAPI documents primarily. And this sort of allows us to compress our timescales down a little bit. It means that we can probably do more of, we'll be more rigorous kind of upfront in our API design by virtue of having to produce a specification together. We can generate mocks from OpenAPI, although I'm going to talk about that a little bit more in a moment. We then, crucially to my last bullet point on the previous slide, we end up producing something which has got long-term value throughout our process. By building up an OpenAPI document alongside the implementation, we have something we can use for validation, documentation, configuring API gateways, all of that kind of stuff. So this definitely improves matters, but it still has a number of shortcomings, I think, as a process overall. One being that sort of people don't tend to want to sit straight down and write a specification from scratch. What I've observed about a lot of software teams, and I think techniques like BDD kind of are really testament to this, is that they tend to think in examples first, to build up a load of specific examples for specific use cases, and then to eventually kind of extract a model from that more generally. And so I think, in my observation of the way people work, is that there's still something that has to happen kind of to the left of the collaborative spec authoring to really think through those examples and bring them to life before committing them to a specification. So that's one thing. As we said, the maybe some verification is shifted left, or some sort of QA on the design of the API, but still, most of the real meat of that happens when you're writing client code against something that it can run against. So we still end up with a lot of this happening late. And like I said, you can generate mocks from OpenAPI specs. A lot of tools will do this to some extent now, but in most cases, it's a fairly limited process. OpenAPI isn't designed with mocking in mind specifically, and as such, the information that OpenAPI, at least in its kind of standard scheme of things, doesn't make for generating particularly rich mocks. You can generate some basic sort of happy path cases from it, and you can use that as a way of kind of illustrating how the basics of the API work. But for kind of serious development and testing processes and serious kind of deeper onboarding processes, the mocks generated in this way tend to come up a little bit short, and that's part of the reason why a lot of this feedback still arrives late, because the testing you really have to do at client code requires a certain sort of depth of behavioral simulation that you tend not to get from auto-generated mocks from most of the tools out there at the moment. So I'm going to propose that there's a better way still to collaboratively build APIs in this way, and this is what we're calling mock-based prototyping. So this is where, rather than doing this kind of example generation, sort of brainstorming process, instead we we go and collaboratively build a mock API, kind of, you know, as we're thinking aloud. And we got this idea because we observed some of our customers were doing this sort of well before even we thought about this as a specific use case for our product. But they were going into a room and you know, typing their kind of mock examples, so their examples, turning them straight into mock API. So by the end of the design session, they would have a working mock that they could go away and start building against. And you know, obviously this has a whole load of examples over above the sort of previous two processes that I was illustrating. The obvious one being that as soon as you leave the room, you have a running mock, and therefore consumers can start writing code against this straight away. So you can start that process of validating the API design from day one. You can do a lot of the heavy lifting in terms of generating OpenAPI. So when you want to feed this downstream into kind of API design, governance, you know, all those kind of processes, you've done a lot of the work already in building up your examples in terms of being able to generate OpenAPI. So it's labor saving in that regard. You know, we have some sort of further downstream benefits from having produced these artifacts in this order. You know, we have the mocks continue to be available for kind of CI/CD, you know, for consuming teams when they start running automated tests against the client code. They have the mocks ready made to validate those against. And lastly, the presence of a mock means that you can put it behind a documentation solution or developer portal and use it as essentially a ready-made sandbox, which is great for people who want to kind of learn how this API works and while they're onboarding themselves. So I've given enough of the theory, I think now, and I'm now going to show a quick demo of WireMock Cloud, so our cloud product, which recently got a load of workflows added to it, or a load of tooling around it to enable this kind of mock-based prototyping workflow. So I'm going to do a quick demonstration of how that might work. So hopefully, okay. So here we have an empty mock API. So it has no stubs in it. So stubs are WireMock's kind of unit of configuration, I guess. So they and they're essentially examples. They're request response pairs. So kind of saying, if we get a request that looks like this, then return a response that looks like this. And they can be quite simple and sort of everything hard coded, or they can be quite rich, both in terms of the matching logic that you use, and also the ability to kind of dynamically generate responses and enable some complexity there if you need it as well. But what I'm going to demonstrate is taking some sort of hypothetical payment service API, within it. So we're in a microservice environment and we want to be able to charge customers. So within our API, so it's probably worth me pointing out this first as well. So this is the OpenAPI view. We get this kind of OpenAPI doc just with header information in it, nothing interesting at the moment. And then we get this toggle switch saying generate or enable public API documentation. So if I switch this on and click this link, then as you can see, we get these documentation pages. And again, they're not very interesting at the moment because there's no behavior configured in this mock API. Let's next assume that this API already exists, and so it has a little bit of functionality. And what we want to do is start with what we've got, and then kind of prototype the next set of functionality that we need. So we'll start by going and pulling out. So say we've got this. We've already defined, the ability to work with customers in our API. So I'm going to go and paste this into our OpenAPI doc. So we have at this point, just the ability to get a customer by ID. I'm just using this to illustrate the sort of pre-existing API behavior support that we've got here. So if I hit save, we should now be able to go over to our stubs page, and we've now generated a couple of stubs. So this means that I can go make a test request for this particular user's details, and I get a response back. So this means I can start testing against this mock straight away with the existing behavior. I can also now go over to my API documentation. As we can see, it's added what we put into the OpenAPI doc and generated some nice docs for it. And I can go and make a test request from in here, and I can get the same kind of response back from here as well. So far so good. But this is at the moment just kind of taking OpenAPI and documenting it and generating a mock. What I want to demonstrate is we can also go the other way. So this type of mock API within WireMock supports kind of essentially bidirectional generation. So we can start with OpenAPI and it will generate mock API behavior in the form of stubs, or we can create stubs and that will generate elements within the OpenAPI doc. So let's say we now want the ability to create a new payment, and we post some information in the request, and then we get kind of an enriched version of that payload back as a response. So fairly typical API design. So I'm going to create a new stub, which is going to be called create new charge, and it should probably be a post, and we'll say that the URL path is just going to be charges. So fairly typical sort of REST pattern where we post to a collection. I'm going to set up a specific body matcher because this will illustrate what we're doing and also help with the OpenAPI generation. So let's say we want to go, we've got a new charge will look like this. This is what a request will look like. So we want the customer ID, we want the currency, and we want the amount that we're charging. And then in the response, we will probably get back something that looks quite similar, but there's some enrichment around it. So we've generated an ID for the charge. We've got a customer link, we've got a creation date and a status. So that should be about it. So now if I save this stub and then I go back to the OpenAPI page, we'll now see that we've generated all this OpenAPI information. So we have schema and examples for the request body, same for the response as well. So a lot of this, like I say, this sort of heavy lifting has been done in terms of sort of generating the OpenAPI. And if we change our mind, if we go and make edits to the stub, then this will be reflected in the OpenAPI as well. So it supports this nice, sort of rapid prototyping workflow. And again, now if I hop over to here, we'll see it from this one stub, we've now got all this nice documentation again. So we've got both request and response schema elements documented. Again, we can make a request and get an example response. And hopefully it's evident that because that was very quick and easy for me to do, and it's cheap and easy for me to change my mind, and we can sit during our design session, we can add more of these stubs to add more examples of different variations of behavior. This is the crucial thing with starting with a mock, is that we're not limited to sort of one example of good behavior. We might get sort of several different variations. For instance, the payment state in the response could move from sort of pending to succeeded or pending to failed. And really, in order to test properly, we probably want to be able to represent all of these states and to be able to set the matching system up so that we match different requests with different responses and can check all of these cases. So we can build these up as we're working collaboratively, find all the relevant examples, and then these become kind of nicely documented in our sort of developer portal page, and consumers can use this. So one final additional thing I'm gonna quickly demonstrate that we can do here as well. So sometimes, so when we're working with kind of static stubs and so on like this, we can also generate in both directions. We can take a piece of JSON and say, okay, I know how to turn this into a schema, or I know how to take a schema from the OpenAPI and turn it into an example. But we sometimes, so if we're using response templating, which is an advanced feature of WireMock, then we can't sort of make that static evaluation, but we still want to validate that our mock API and our open API are kind of in sync with each other. Or maybe if we just have other processes kind of outside of all of this for producing the mock API and the open API, and we want to check that they agree with each other, we can use this new validation feature. So first of all, what I'm going to do is go into OpenAPI. I'm going to say soft validation mode. So this just means it's going to let things continue working, but add validation errors or add validation messages into the request log. So this is the first thing we'll do. And then what we're going to do is get a copy of this charges stub. And we'll say that this is the bad version this time. I'm going to turn response templating on. I'll get rid of this body matcher just so we can put whatever we like in the body, so it's not constraining it. And then maybe let's start with messing up the, well, in fact, no, I won't do that. So we've got a valid response still. We'll save this. So now if I go and make a request, and let's say we this, but we remove the currency from there. So currency is a required field. So I'll hit send on that, and it still works. Like I say, it doesn't break anything if I violate the validation rules. But I can now go into the request log, and it will show me what's happened. But you see now I get this validation report attached down here if there is anything, and I can expand this out, and it will show me what I sent, and it will show me what the where the snippet of the OpenAPI doc that this relates to. So I can see very clearly how my request hasn't matched up with the OpenAPI doc. And the great thing about this is great for consuming teams, because they can see whether their calling code is working correctly or not. This will tell them in a lot of detail what the problem is. And likewise, I can go and do a similar thing for the response as well. So let's this time go and remove, let's say, the amount, which is also required. And I'll go and do the valid request body in this time and send it. Go and look in the log. And as you can see, this time we've got a response validation, and it's similar kind of affair, but this time it's validating my stub. So if my mock, but essentially what this means, if we've got response validations, is does my mock API agree with my open API kind of at runtime based on the traffic observed. So even if you've done complex stuff with response templating, so if I'd put a load of dynamic placeholders in here and it wasn't possible to evaluate sort of statically what the whether this would be valid or not, we can now kind of at runtime, when we're running our automated tests, we can check whether or not the two agree. And that's about it. So thank you very much for listening.